Hello again. So this question is from paper 2 June 2023 and it's the last one. It's the last question. And so we're going to be solving it right now. Inshallah. So this one is all about the specific heat capacity. Now it looks like it is about electricity and blah blah blah. No, it's just about the heat capacity. And I'm gonna show you a way that even if they ask you to find or to make a method or an experiment, you can find your way around it. Okay, so here they're saying like at a roof of some house, I don't know, they provide concrete to use to heat the water. So here the photograph shows a concrete and water heating system being built into a roof of a house. And scientists want to determine the specific heat capacity of concrete. The diagram shows some of the equipment they could use. Okay? Now, this part here, all of this is to heat, is for the electrical heat, to provide the water inside this water here, to provide it with energy in order to be heated. Tamam? So this whole experiment is to find out the specific heat capacity for the concrete. And so we heat the water in order to be on the same, it will be in equilibrium with the concrete, and then we can find the temperature of the concrete, right? This is the idea of the water bath. So let's read the question. Describe a suitable method to find the specific heat capacity of concrete. Now, when you want to find a specific heat capacity and you just don't know from where to start, also these are 5 marks to try to collect, here's the first step you do. Write down the equation, the formula to find the specific heat capacity. Now, it is originally that way, right? MC delta T. But I want a specific heat capacity, so I'm gonna rearrange it, and it's gonna be over M delta T. Okay, let's go try to find, this equation is going to help us find the specific heat capacity, and this is the question they're asking about, the specific heat capacity. So let's start one by one. Let's start with the mass. It seems the easiest to be found. The first thing that we should think about when we try to make or design an experiment regarding specific heat capacity is, how can I know or report the mass? Well, you will have to use a balance. Now, how to measure the mass is using a balance. This is for the mass, and you're gonna get a point. Now, how to find the temperature for the concrete? You're just gonna put the concrete on a water bath in order for them to be on the same equilibrium, heat, thermal equilibrium. And so you're gonna find out the temperature, the initial temperature of the water, and then the final temperature, and you just subtract them, and you're gonna get the delta T. But what are you going to use in order to find out the temperature of the water? You're gonna use a thermometer, right? Right. So this is another point you're gonna get. What else do we need? Here, the Q. Q is actually energy. Q is just another way of saying thermal energy. So it's the same as E. But here we don't have a fire. We don't have, what is our source of energy? It is this circuit here. And so we know that power is equal to what? Is equal to energy over the time. It's the rate of energy, right? And so I want the energy, I don't want the power, so we know that, but just rearrangement, and we're gonna get that energy is equal to PT. We don't need you here. So, yep. And here we know now that thermal energy is the same as the electrical energy, since here the electrical energy coming from this part is the one responsible of heating the water. Just transfers from electricity into thermal. So those two are equal, and so we can find the energy using the power from the power supply times the time. For the time, we can use a stopwatch to report the time or to measure the time. What about the power? How can we get the power? The power, if you remember, it is equal to VI. How did I know? Even if you forgot, you will find some hints in the question. You see, we have ammeter and we have voltmeter. Both of these readings are going to help you find out the power. So you're going to say that the power, we can find it by what? Multiplying the voltmeter reading with the ammeter readings, because this is the formula for finding the power. So after you do that and you measure the time required for the water to be heated to a specific temperature, you're gonna find the energy. And so you can go back to this. You can use this now, and everything is already given to you. So just simple math, but you don't have to go through this. You're just gonna say that you're gonna substitute the values you got from your equipments, and you're gonna get your specific heat capacity. If you want to add more information, you can draw the time temperature figure, the diagram. And if you forgot about it, this one, when you do this, and then you have your boiling point, and then again, and then here, you see, remember that one? In the method, you can use this graph as well. It's called the time temperature graph, where you can know a lot about the specific heat capacity from the gradient, from other stuff, and it can give you another point. There are a lot of other things you might add, which one of them, and that you will be using different temperatures, and you're gonna repeat the whole thing and get the average. This is another point to get it. So you see, you can say it in different ways. It doesn't have to be on one way. But if you ask for my advice here, just write the formula and try to find those guys. This is the energy, as I mentioned. So all you have to do is finding the power and the time. The time, you're going to use a stopwatch. The power, you're going to be going back to this circuit, and you're going to read the voltmeter and the ammeter, and you multiply both of them. You're going to get the power, times it with the time. You're going to get the energy, and the energy back to the specific heat capacity. For the mass, you use a balance to measure the mass. For the temperature, you use a thermometer, and then you find the temperature, the final temperature minus the initial temperature. And you can repeat this a couple of times to get the average. Also, you can draw a graph in order to find out more about it. Now, basically, I said way more than 5. You can choose 5. If you remember 5 out of these things, then that's perfect. So this is for which bar? A. All of that in A. So, for B, explain the advantages of concrete having a high specific capacity when it is used to heat water in the heating system. Now, what do we mean by high specific heat capacity? It means that in order to raise the temperature of this concrete only 1 Celsius degree, you will have to give it a lot of energy. So one advantage is that since the concrete has a high specific heat capacity, it absorbs a lot of energy, and so it releases a lot of energy as well. So the water can be heated quickly, because true, it's gonna take time to absorb the heat from the surrounding. However, it's going to give the water a lot of, gonna release a lot of energy at the same time, because good emitter means good absorber means good emitter. So a lot of energy is going to be absorbed, so a lot of energy is going to be released and given to the water, which it's going to be heating it, right? And this is what we want from the concrete in the first place. This is number one. They're asking for another point. Number two, since it's not going to, we need a lot of time in order to absorb a lot of energy if you have a high specific heat capacity. And so this concrete will not lose its energy fast. It's gonna take a longer time to lose its energy. So even if we don't have some kind of source of heat in the surrounding, let's say at night, the concrete won't lose its energy that fast, and so the water inside of the concrete will stay warm for a longer time. We can say that the temperature of the water will maintain warm, or it will be maintained for a longer time. I hope it's clear.